This lecture is all about motion. So the first type of motion we're going to deal with is linear motion. So linear motion is motion in a straight line. So there are 6 terms that describe motion. So pause for a minute and just try to think to yourself, what are the 6 terms that describe motion? Can you come up with 2 or 3 of them? Okay, let's take a look at the list. We have distance, displacement, time, speed, velocity, and acceleration. So through the PowerPoint presentation here, we are going to take a look at these 6 different terms and understand them a little better. Distance and speed are what we call scalar quantities. So a scalar quantity is something that only has size or magnitude, but no direction. So if you look at our picture down here of the stick man, you can see that he starts at 0, he walks to the 6-meter mark, and then he turns around and walks back to the 2-meter mark. The total distance he traveled was 10 meters. Although he's only 2 meters from where he started, his overall walking distance is 10 meters. So this is like your steps, right? If you're counting your steps, right? We're all told we should count our steps, we should wear our little Fitbits and walk around. So we go back home at the end of the day. We leave home in the morning, we walk all day, we take all these steps, and then we get back home. The total distance we walked would be our number of steps. We're back home though, so we haven't gone anywhere. Or if you're on a treadmill, you can run 5 miles, right? That's a distance that you ran, but you didn't go anywhere. That's a magnitude, that's a size. The direction is insignificant. Same thing with speed. If I'm in my car and I'm driving 40 miles an hour, that just tells me how fast I'm going. It doesn't tell me where I'm going. And that's why they're called scalars. Scalars only give you the size. They don't give you the direction or where you're headed. A vector is something that gives you both magnitude and direction. The first one, displacement. If we think back to the stick man in the previous problem, what was his displacement? How far is he from where he started? Well, he traveled a total distance of 10 meters, but he's only 2 meters from where he started. The 2 meters is this displacement. If you talk about the Fitbit and the steps, right? You start at home, you end at home. Your displacement is essentially 0. You're in bed at night, just like you were in the morning when you woke up. You've gone nowhere, essentially, throughout the whole course of the day. Your displacement from start to finish is 0. Time is a vector, right? We know time moves in a direction, it moves forward. Velocity is a vector. Velocity is speed with direction. So if we're going 40 miles per hour, like our previous example, and we're headed east from Lancaster, that gets us to about Philadelphia. So this gives us a direction. We know where we're going. And then acceleration. Acceleration is how fast you change your velocities, the rate of your velocity change. So you can have a positive acceleration. We usually associate that with speeding up, and a negative acceleration, which we usually associate with braking. Vectors are represented with rays. It has a start and a finish. The start would be your tail, and your head is the direction you're moving in, which gets you to your finish point. Here's a picture of the difference between distance and displacement. You can see distance, we go all around and about and get from point A to point B, where the displacement would be as a crow flies, the straight line between A and B. Your displacement will always be less or equal to your distance. You can't have a smaller distance than your displacement. Speed is the rate that you cover a distance. It's the distance traveled with respect to time. We have 2 types of speed, average speed and instantaneous speed. The formula for speed, S equals D over T, and you can see that bar on top of the S, that means average. Anytime you see a bar on top of anything, that means average. If you're using Excel and you're trying to average all the value or find the mean of a bunch of numbers, it has the bar over the top of it. That's what that represents. So we talked about in chapter 1, that formulas represent definitions. So let's look at our definition up here. Distance traveled with respect to time. That's their speed. And here's our formula. Speed equals D over T. So D is your distance over your time. And you can see how the formula represents what speed is. Instantaneous speed is your speed at an exact moment in time. In your car, we use a speedometer to know our instantaneous speed. A cop uses a radar gun. Radar travels at the speed of light. That's instantaneous. So by the time you see the cop, he's already got your speed about 100 times because that gun is firing back and forth instantaneously. So instantaneous speed is your speed at an exact moment in time. Cops can also get your speed using your average speed, which is your speed over a period of time. So that's called the VASCAR system. Those are those white lines on the road. So when your car hits the first white line and then it hits the second white line, they can time it takes you to go between the lines, and they know the distance. They can take the distance over the time and find your average speed. We use average speed all the time. Let's say we're going to our grandma's house and our grandma lives 30 miles away, and it takes us an hour to get there. So if she lives 30 miles away and an hour to get there, what was our average speed? It was about 30 miles per hour. So when you think about all the times that you go somewhere and you kind of figure out how fast you can go and how long it's going to take you to get there, that's your average speed that you're talking about. Velocity is how fast and the direction that you're moving in. You can see this airplane flying up here has a crosswind, so you can see it's going straight and being blown to the side at the same time. So this is what we call a velocity vector. It's going two directions at once. If you take a plane trip across the country, your trip home goes a lot faster than your trip there because the jet stream. When you're going against the wind, you're going to go slower. When you're going with the wind, you're going to go faster. So your velocity is your speed and your direction. You can see the formula for average velocity is displacement over time. Displacement is delta x. That triangle in front of the x, that's a delta symbol. It's a Greek letter, and delta means change in. So that would be your change in position over time. That's your average velocity. And our final term that we're going to deal with is acceleration. And your acceleration is how fast you change your velocity. So we can have a positive acceleration and a negative acceleration. The positive acceleration means your velocity is increasing over time, and a negative acceleration means your velocity is decreasing over time. So the picture on the left of the race car, that thing is increasing with time, and then the tractor trailer going up against that Volvo, as it's slowing down, it has to decrease its velocity in a period of time. So acceleration is your change in velocity, delta V, over time. In your car, you have three major accelerators. The first two are the brake pedal and the gas pedal. The brake pedal gives you a negative acceleration. The gas pedal gives you a positive acceleration. The other accelerator is your steering wheel. As you change your direction, you are also accelerating. Remember, acceleration is change in velocity over time. Velocity is speed with direction. So if you change your speed and your direction, or your direction, you're accelerating.